Welcome to this presentation on Rockwell Hardness Test. We will discuss about the principles, we will discuss about the demonstration, and we will also bring a video directly from the lab. Now let's discuss about the hardness. Hardness is a material's resistance to permanent deformation such as indentation, scratching or wear, and common hardness tests include Brinell, Vickers, Rockwell, Moose, Snoop. So why Rockwell? Because this is fast, this is simple, and it requires minimal surface preparation. What is the principle? A steel or tungsten carbide ball, or a diamond cone indents the material. So you can see here, this is the tungsten carbide or diamond cone. Okay, and this is going to indent the material. This is the material. This material you can see. This material we are going to test. Okay, we are going to test the hardness of this material. We sometimes call it TS. In the lab, you will find it like this. And the hardness value is displayed directly on the machine. You don't need to figure out the value from here, and then you don't need to put them in any formula to get the value of the hardness. You can directly get the value of the hardness from the machine or the dial or the display of the machine. See, at first you need to place the specimen on the anvil, then you apply the minor load, which is 10 kg, to set the position, and after that you may apply the major load for the penetration, and major load is 100 to 150 kg for metals. And then you wait for some time for 30 seconds to 1 minute, and then you release the major load, and you can measure the indentation depth, and you can read the hardness value from the dial or digital display directly. Okay. Now see, there are different Rockwell scales, Rockwell hardness scales. So HRC, which is Rockwell C, HRB, which is Rockwell B, HRA, HRF, HRG, etc. So there are different variations of the Rockwell hardness scales. Now let's see what are the factors that can affect the hardness test accuracy. Surface preparation. So rough surface can affect the readings, and specimen thickness. Too thin material may give the incorrect values because we are going to penetrate that. So as we are going to penetrate, it cannot be too thin. The action of the penetration can break it, or can directly entirely penetrate it. We don't want that. So load selection, the wrong load can damage the specimen or give false values, and indentation location must be away from edges to prevent the errors. Today we are going to test the hardness of this test specimen. So I am keeping it on the anvil. And as I am keeping it on the anvil, you can see you can see the indenter, which is made of tungsten carbide or diamond. Okay, and there you will find 120-degree angle. So as I rotate this, this in this direction, it will move upward. It will go upwards, right? Okay. So see, now I am moving it in this direction. So it will move upwards. It is moving upwards. Now okay, so just move it from the edges so that you can get a more precise value. And now you can see there are two scales. One is a larger, one is bigger, and there is another smaller scale you can see with a dial. So two dials are there. Okay, one for the minor load, and the bigger one is for the major load, while the smaller one is for the minor load, which we are going to apply now. We are going to apply two loads. At first we are going to apply the minor load, and then we are going to apply the major load. Now see, now as I am moving it upwards, the scales dials are going to start rotating. Okay, I am moving it in this direction, in the upward direction. Okay, so the scales are also moving. You see, the scales are also moving. So as the smaller scale will come closer to the red dot, you don't go beyond that, okay, because it can damage the dial. So you just rotate in such a way so that you reach to this red dot, and reaching to the red dot means you have already applied 10 kg load on this test specimen. Okay, and after applying the 10 kg load on the test specimen, what is your requirement? What do you do in this procedure? You apply the major load, right? So after that you will load 100 to 150 kg major load, and you will wait for 30 seconds. Okay, as I moved up, I touched the red dot. You can see here, I touched the red dot, and after touching the red dot, I won't go upward anymore. Okay, so now I am not going to apply any minor load. So now I am going to apply the major load. Here you have got the load and unload option. So as you load it, you have applied the major load. Okay, so 100 to 150 kg load is being applied on this test specimen right now, and we are waiting. Okay, we are waiting for 30 seconds to 1 minute. Okay, so and as we are waiting, you can see that the dial is also moving. Okay, so after a few seconds, after 30 seconds to 1 minute time duration, what you will do is you will unload it. You will unload the 100 to 150 kg load. Now we have unloaded. Okay, as we have unloaded, you see that we have got a hardness value. Okay, now as we have got the hardness value, you can see. Okay, so as you will unload it, you will directly get a hardness value. So this value is the hardness value of this test specimen. So for more such videos, like, share and subscribe, and thank you so much for watching till the end. Have a great day.